Assalamualaikum warahmatullahi ta'ala wabarakatuh. My name is Rahmat Faisal bin Ramzan, metric number MH10001. In this video, I would like to tell you about computational fluid dynamics, or in short, CFD. Let's start with the introduction. CFD is actually a branch of fluid mechanics that uses numerical method and algorithms to solve and analyze problems that involve fluid flows. CFD have been widely used in industries due to its huge advantages over the conventional way of having all the huge and expensive device. Common software used to analyze is ANSYS. Now I would like to explain to you about the analysis steps from the very first steps of doing the analysis. From step 1, we must create a geometry drawing. This is also means importing the geometry from other CAD software is also possible, such as AutoCAD or SolidWorks. And in my report, I use SolidWorks to generate my geometry, and then I import into the ANSYS software, or better known as Workbench. The second step is we must create a mesh for the imported geometry. Pay attention on the critical portion of the geometry. According to the mesh, it is being meshed at all around of the car. The critical portion of the car is such as at the frontal of the car and the windscreen, and maybe at the back of the car a bit, because that's where the flow of the air or flow of the fluid will be more concentrate. So the mesh must be more smaller. Step 3 is we must set up the boundary condition. All setup must be correctly set, or else the result will be wrong. This is include the type of the flow, the velocity, the viscosity, the density of the flow, and the material of the car that we are using. All of that must be set up correctly, or else the result will not be something good. So the last step is we must iterate the conversion and wait until it is finished. So after the iteration is finished, let's say 50 iterations, then we will get results such as this, and we will analyze from the ANSYS software, where we can choose the options where we want to see the simulation of the vector, velocity, contour, or maybe streamline. Why use CFD? This is another way of saying that the CFD has some advantage over the conventional use of the huge and expensive device. Firstly, it is time saving. CFD analysis can be carried out in a short period of time. Secondly, ability to stimulate real conditions. Many flow and heat transfer processes cannot be easily tested. This is maybe due to the temperature is very high that human cannot extend to which their device being used to test the experiment, or maybe the flow of the fluid is very high that we simply cannot stimulate in real world. And the lastly is the major reason why people use CFD. It is due to the low cost of conducting the experiment, because using physical experiments to get essential engineering data for design can be expensive. This can be proven by the analysis of airflow in around a car, because by having a wind tunnel, which is very expensive, people started to use CFD to replace the conventional wind tunnel, which costs a lot of money and time and also manpower. So I think that is all from me. Thank you very much.